Welcome to Geometry, Section 4.1, Congruent Figures. So today we're going to look at different congruent polygons. Here I have some pictures of different ways we can move polygons around, and sometimes it makes them look different, but they may still be congruent. So on the first part we have the slide, where I take a rectangle and I just slide it up and to the right. It doesn't change the figure, it's just moving where it is. The second picture I have is a turn. So what I've done is I've taken a triangle and rotated it and turned it around so that this bottom side is now on the top. That again doesn't change the figure, it just changes its position. And here the third picture is of a flip. So I have this four-sided polygon that I just flip over, and so the side BC flips over and is in the same position as the side QR. So if I were to flip the left polygon, I could lay it right on top of the right polygon and it would match. So if I'm looking at these two polygons in the flip picture, I can see that when I flip the left polygon over, angle C and angle R would be the same, and because they're in the same position. So we have underneath here, I've written congruent polygons have congruent corresponding parts. That includes angles and sides. So if I know that these two polygons are congruent in the flip picture, then when I flip the left polygon over on top of the right one, I can see where their corresponding parts would be. So angle B and angle Q are corresponding. That means those would be congruent. Angle C and angle R were corresponding, so that was why we got those were congruent. Angle X and angle Y would be corresponding. Angle A and angle R would be corresponding. Angle P, I'm sorry. Angle A and angle P. And I could also look for corresponding sides. So we started in my example here, the line segment AX, or the side AX here, is congruent to the side PY, because those are corresponding. Remember, corresponding means they're in the same position relative to the other things in the figure. We use those with parallel lines and transversals, but now we're looking at polygons. So if I were to flip the left polygon over, the side AX would be in the same position as the side PY. So those two would end up being congruent. The other sides that are corresponding can be seen in these figures. So see if you can find the three other pairs of sides that are corresponding. You can pause this while you try to look for them. Okay, so side XB would be corresponding to side YQ. Side AC would be corresponding to side RP or PR. Oops, I wrote Q. And side BC would be corresponding to side QR. So if I know that those are corresponding angles and sides, then I could also come down and say that those are congruent to each other. So I could say angle B is congruent to angle Q, and same thing for the other angles, and I could also say the sides were congruent. So side XB would be congruent to side YQ. Okay, so it's important when I'm naming congruent polygons to make sure that I list the corresponding vertices in order. So remember, the vertices are where the lines come together. So in this example, vertices would be T, D, J, F, R, C. Now, when I look at them, sometimes they will tell me in advance that the two figures are congruent, and I can use the way that they list the vertices to name congruent corresponding parts. Sometimes if I know which parts are congruent, I will have to come up with what order to put the vertices in. So this time in example 1, we are given that triangle TJD is congruent to triangle RCF. So if you look at the order that these are listed in, the first two letters that are listed are T and R in each triangle, so that tells me that those angles will be congruent. So angle T is congruent to angle R. Now, looking at the order of the triangles, the vertices that are listed tell me two more pairs of angles that would be congruent, the corresponding angles. Okay, angle J is congruent to angle C, and angle D is congruent to angle F. It's important to know how the way they list the vertices can help me, because sometimes when I look at the picture, it's difficult to tell which vertices are supposed to be congruent, especially in a figure where the sides are similar lengths as they are in this one. So if I go by the way that they listed it, then it helps me to make sure I get corresponding parts in the right place. So now if I look at the sides, I can also use the way that they've named. Wait, that's not what I want to do. Okay. So when I start looking for the sides, I'm going to look at pairs of letters. So the first two that are together are T, J, and BC, or RC. Let's look at B. So TJ is congruent to RC. Alright, if I look at the next pair, JD and CF would be congruent. Okay. And then the last two I need to do the outside letters. So T and D should be congruent to RF. Now notice that if you had been looking at it a different way, you might have written DT as congruent to FR, and that would be okay too. So if you reverse the order of the sides, the letters in the sides, that's okay as long as you do it in both TJ and RC. I could write JT is congruent to CR, but I have to make sure I reverse both of them. So I'm looking at the order that it was written down in, so I can choose how to find my pairs of corresponding parts. Now remember also, we can label these on the diagram. Angles that are congruent to each other will have an arc drawn through them, either 1 or 2 or 3, depending on how many angles we've marked in the picture. So I went ahead and marked angle T and angle R congruent. If I want to mark J and C congruent, I will use 2 arcs, so that I can make sure I can distinguish which angles we're talking about. And then if I wanted to mark D and F, I would do 3. That way it's easy for me to see which angles are congruent from one figure to another. The same works for the sides. So if TJ and RC are congruent, I could mark it with 1 mark. Let me change colors. the difference from the angles. All right, so I'd mark one mark for that one. JD and CF, I could mark with 2 lines. And TD and RF, I could mark with 3 lines. Okay, so we know that congruent polygons have congruent corresponding parts. If I want to show that 2 polygons are congruent, triangles or otherwise, no matter how many sides they have, I would need to show or make sure that all the corresponding parts were congruent in order to be able to say that the triangle or the polygons were congruent. Okay, so here they've given us 2 polygons and they've told us that they're congruent. So if I know they're congruent, then I can assume that their corresponding parts are congruent. They're asking me to find the measure of angle B, which is here. So one of the first things I want to do is look at the other figure and find the corresponding angle. Sometimes they're labeled in the other figure. So over here I would find angle E. Those are the ones that are corresponding. If I flipped over the left or the right polygon, it would lay on top of the other one. And it would help me see which parts are corresponding. So angle B will be congruent to angle E. I guess I should have just said equal since I have measure written there. Now I have to figure out how the measure of angle E was not given either. So I've got to figure out how to find that. And if I look at the left figure, I see that they've marked 2 of the angles, 132 degrees for angle C and 88 degrees for angle S. And then the A and the P are marked as right angles. So remember that for a polygon, we can find the sum of the interior angles by multiplying how many sides there are minus 2 times 180. So in this case, the sum of the angles should be equal to 5 minus 2 times 180, because each of these polygons has 5 sides. Right, so that's going to end up being 540. That's the interior angles. So what I'll do is take the ones I know. I know I have 2 right angles, those are measured 90. 90 plus 90, that's A and P. And then I'm going to add the other 2 I'm given, so 88 degrees plus 132 degrees plus the measure of angle E, whatever that is. We don't know. That should equal 540 degrees. So if I add up all of the ones I know, 90 plus 88 plus 132, I get 400. So 400 plus the measure of angle E should equal 540. Then I'll subtract 400 from both sides. I'm going to end up with measure of angle E equals 140. And since the measure of angle B is the same, because these are congruent polygons, which means that corresponding parts are congruent, then I can say that the measure of angle B is also 140 degrees. And that's the question they asked me. So make sure you don't get lost doing this other work and forget to actually give the answer to the question. Okay, and here they asked me to find congruent triangles. And so I'm going to be looking at the triangles that they've drawn, and I'm going to try to figure out if they're congruent or not, and then I have to justify my answer. So they've given me some information. The 2 triangles drawn are kind of funny looking because they share one line is making up the sides of 2 different triangles, but they're joined from A to E. And so I'm looking at these 2 triangles, the one on the left, ABC, and the one on the right, EDC. And I'm going to try to decide if they're congruent or not. So remember, what we have to know is, are all the corresponding parts congruent? Okay, I've been given some information. I do know that angle B and angle D are congruent. That's given to me because they're both right angles. And then this looks like I tried to mark a right angle, but it's really just an arc. These two angles, angle A and angle E, are also congruent. That was also given. They also marked some of the sides. So they marked the sides, let's see, AC and EC. That's just the line through each side, means those are congruent. And then they told me that the measure of angle AB is the same as the measure of angle ED, that side. Those are both 3, so there's another side. AB is congruent to ED. Now notice when I write these down, I'm kind of being careful because I'm writing down the in a certain order. So AB, that side, is congruent to ED because A and E are the congruent angles and B and D are the congruent angles. So even when I'm doing writing my sides, I want to put this in an order so that the angles that are congruent come in the same order. So A and E come in the same order because they were congruent, and B and D come in the same order because they were congruent. This will help me when I write down my triangle congruent statement. So right now I've got 2 angles and 2 sides. They also said that angle side BC is 4 and side DC is 4, so I can say that those are also equal, or congruent. And again, I'm writing them in order of the angles that are congruent. So BC, the B is congruent to D, so I write D first, and C is congruent to itself. The only thing I don't have now, I've got 3 sides are corresponding and congruent. I have only 2 angles, so I need one more angle. The other angle there, you can't just say angle C this time because there are 2 different angles at angle C. So if I'm looking at angle BCD, wait. All right, angle BCD is this angle that I'm drawing in blue. I'm sorry, BCA, not BCD. And then I look at angle DCE. I need to know if these 2 are congruent. This is my last pair of angles. So if I look at the picture, I can realize that these 2 angles are vertical angles. Their sides form a straight line with the other angle. So from B to C, and if I continued on to CD, that's one side of the angle, and then A to C and C to E, that's the other side. So these 2 are vertical angles, which makes them congruent. I think it was called the vertical angle theorem that told us that vertical angles are congruent. But if you don't remember that, you can just write that out to the side, because I'm justifying. This is why I'm doing it. So now I have all 3 pairs of angles that are congruent, all 3 pairs of sides that are congruent. Once I get there, then I can say that the triangles are congruent. I'm going to be careful to put them in the right order so that their corresponding angles or corresponding vertices line up. So I'm going to start with triangle ABC, just putting it in alphabetical order. That's congruent to triangle. Now I'm going to be careful. A was congruent to E, so E comes first. B was congruent to D, so D comes next. And C was congruent to C. So that comes next. So if I had to justify that, I would say all corresponding parts are congruent, because I just went through the whole list up here. Okay. Finally, they give us a little bit of help in trying to determine things a little quicker. Theorem 4.1 says that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. The third pair is what they're talking about. So in this picture, I have drawn triangles ABC and EDF, and I have marked that A and D are congruent, and angle B and E are congruent. So this theorem would conclude that since there are two pairs of angles that are congruent, that the third pair of angles is congruent. So why is that true? Think about it. Why would that be true? Okay, if we remember the triangle angle sum theorem that said that the interior angles of a triangle have to add up to 180. So if B and E are the same and A and D are the same, then when I add B plus A and E plus D, I would get the same thing. And whatever that is, I would subtract from 180, and that would give me F and C. So we kind of come around about that with using and thinking about the interior angles of a triangle adding up to 180. Now, this is something, once we have this theorem, we can use it as we're trying to do other proofs, which we're going to do a lot of in this chapter. So example 4 asks us to prove that, let's see, which triangle? I want to prove that triangle PQR is congruent to triangle PSR. So it's kind of like what we were looking at in the last problem on the last page, except this time we're going to write it out as a two-column proof. So the picture gives me some information, and I've already have it written down in a couple of the things that they've drawn in the picture into my statements. So on number 1, I've got PQ, the line segment or the side PQ is congruent to PS. They had marked that in the figure. And also QR is congruent to SR. They had also marked that in the figure with their lines, sets of lines. So if they've marked it in the figure, or if they've written it out in the given information, then our reason is just given. The second statement I have, angle Q is congruent to angle S. That is also given. They've drawn the picture in to show me that those two angles are congruent. And also the same thing for angle RPQ, which is this angle, is congruent to angle RPS, which is the other angle that they marked with two lines. So both of those reasons for the first two statements would be given. Now remember, right now we have to show all corresponding parts are congruent. So I've got two angles and two pairs of sides that are congruent. I need to get the other pair of sides and the other pair of angles. So let's start with sides first, since that was our first statement. We had PQ is congruent to PS. We had QR is congruent to SR. The only sides we haven't talked about are PR, and that side happens to be in both triangles. So this one, we will say that PR is congruent to itself. It's the third side in both triangles. Whenever we have something equal to itself, what was the property of congruence that said that we could write that down? It was the reflexive property. Okay, that just, remember, when we look in a mirror, we see our reflection. So that helps us remember that when something's congruent to itself, it's just the reflexive property. All right, so now we have all three of our sides. All corresponding sides are congruent. We just need one more angle, pair of angles. So we did Q and we did S. We did these other angles, RPQ and RPS. The only ones left are the ones down at the bottom that I'm going to mark in red with 3 arcs. I want to show those are congruent. how can I do that? How can I say that angle PRS, oh, let me start with the other PRQ, other triangle first, is congruent to angle PRS? Okay, don't forget the theorem that we just saw. If two angles of one triangle are congruent to two angles of the other triangle, then the third angles are also congruent. So we were already given two pairs of angles that were congruent in the different triangles. So that means we can use theorem 4.1 as our reason for saying the third pair of angles are congruent. Okay, so now we have all three sides, corresponding sides are congruent. All three pairs of corresponding angles are congruent, and that's enough to be able to say that the two triangles are congruent. So triangle PQR is congruent to triangle PRSR. And that is by the definition of congruent triangles. Okay, so also let me note that the last statement that I wrote down is called a congruent statement. Sometimes your book will ask you to write the congruent statement, and what they're asking is write down which triangles are congruent. So just so you know what they're asking when you see that. Okay, good luck with your homework, and circle your questions so you can ask them in class when I see you Thursday.